All right, welcome back, everybody. Again, it's Mrs. Braband. Again, we're going to do Unit 1, Linear Equations, and we're working on Target 5. So we've kind of changed gears a little bit and kind of extended what we were doing before. So we are now doing 2 lines at a time and trying to find the combined answer that makes both of them true at the same time. We call that a system. A system is just something that has more than one math going on. There's a lot of different ways to do this, either substitution, elimination, graphing. Those are the most common ways. I'm going to try to show you everything but the graphing one, and then I'll do the graphing in a different video. Again, when I'm done, I will post it in the same document. You'll see the word video explanation. I will hot link it right there, and then you can look at it whenever you need. All right, let's go to the first one. First of all, you know what? Let me talk about this. If you're trying to figure out, if you've always got lost, like what's the best one to use? Should I use substitution? Should I use elimination? Can we look at all of these here? If you look at just the way they fall on the page, you'll notice the 2 on the ends here and here are stacked so that all the letters are on one side and all the constants are on the other. Letters, letters, equal sign, constant. Those are really good for elimination problems so that we can cancel out, eliminate out one letter at a time. And if you notice, all of them have coefficients that are different than 1. All of them have coefficients that are different than 1. That's a good elimination problem. But the second one has a y by itself. So that entire chunk, that group, is really easy to substitute. So when I do these, keep in mind that I'm doing them because of the way they're set up. All right, so let's go here and say, if I were to add down, add down, add down, not any of these are opposites for the letters especially, so it doesn't help. So what I need to do is I need to create a multiplication situation so that I can rewrite the value of these so that we end up being opposites. I like these signs being opposites, so I'm going to try to get rid of the y's first. So that means I need to look at 4 and 5 and turn them in with multiplication into a number that turns into 0. So 5 and 4 common is 20. So the top one I'm going to multiply by 5 on both sides. The bottom one, in order to make that a 20, I'm going to multiply the top, or the left and the right, I'm sorry, by just 4. I don't need to change my signs because they're already opposites. I'm going to draw a line here just to say that I'm changing the way I write it, and I'm going to write it differently. Distributive property, 25x minus 20y equals negative. Now, I'm guessing Alex might give you a calculator here, but maybe not. So let's just go off to the side. 8 times 5 is 40. 5 times 1 is 5 plus 4 is 9. So that's a 90, negative 90. Again, I don't know whether they'll give you a calculator or not if you're doing the placement test. If it's outside of a placement test situation and you don't need to be stretching your mind that way, obviously use a calculator. 4 times 2 is 8 in the bottom equation. 4 times 5 is 20 positive. That's a lovely thing because look, those are canceled. And then here's 24. So drawing a line again to continue. Now I need to add this down, and that will eliminate something. So 25 and 8 is 33x. This is going to be equal to 0. And this is going to be subtraction. 10 minus 4 is 6. 8 minus 2 is 6. And that's going to be negative. So now I need to divide. That's going to be x equals negative 2. And I'm almost done, but since it's a system, I have 2 letters I need to substitute back in to either one of those. Doesn't matter which one. Always go to your original for safety's sake. And then you're going to work that out. So let's just go to the top one. 5 times negative 2 minus 4 times the unknown y equals to negative 18. I'm just going to the smaller one because it's smaller numbers, easier to do. So we got negative 10 minus 4y equals negative 18. Move your 10 by addition. That's going to be negative 4y equals, looks like it's going to be negative 8. And that's what y equals 2. Now, to guarantee that this is your answer, again, -2, 2, because it's a point. You can leave them separate like that or put them as a point. You could go to Desmos and put both of those equations in, and then you would see where they cross and double check it. Or you could do it another way and multiply by 5 and -2 and get rid of those numbers, okay? You can also check your answers by plugging it into each one and see if it works out. Can we do just a quick check? Let me get rid of this here. I'm going to do a quick check. So I'm going to put both of those numbers in. So 5 times -2 plus -4 times +2. If I did that right, it should be 18. -10, -8. Yahoo! Check the bottom one. 2 times -2 plus 5 times +2 should be 6. We got -4 plus 10. Hallelujah. So I know I'm doing that right. Do you need to check every time? Absolutely not. Absolutely not. All right. Especially if you are very thorough with your steps. Is it a good idea? Sure, but not always necessary. All right. This is the one that's a little different because it has a y by itself. So I'm just going to substitute this whole entire quantity right there and then recopy the way it looks, okay? So 5x plus 2 times y, but instead of the letter y, I'm going to substitute in what its value is. So I'm going to pick its value and put it in, and then continue to recopy. And now I'm just going to finish my math. Distributive property, 2x plus 22 equals -20. And now it's time to just start combining like terms with ease here. Let's move that 22. That'll be 7x equals -42. If you don't see that, I just subtracted 22. Divide now by 7, and that's going to be x equals -6. So there's part of my answer, but I need to grab and substitute it back into the easiest one, which I see as the second one. So y equals -6 plus 11. That's going to give me a 5. So y equals 5. Again, if you want to write it as a point, x first, y second. There you go. So either leave it separate as two answers, separate, or make it a coordinate. Go to Desmos, put both of these in, see if they cross at that point, and then you know you did it right. Do you have to use Desmos? No, it's just beautiful. It's just beautiful. I often say, all hail Lord Desmos, because it's just so amazing and cool. But graphing calculators work if you want to graph it that way too. All right. So again, those are the first two. First was elimination. I'll put that here. It just worked that way. Second one, because of the single y, we did substitution. We could have rearranged it. We could have done elimination if we like it better, but I took it as it was. Second one, there's no single letters, so I'm not going to rearrange. I'm just going to quickly, like we did before, do elimination. I like that these two signs are opposite, so I'm going to choose to get rid of the x. So that means I need to change it to a 6, so multiply by 2 on every side. So let's rewrite it, just like I rewrote it over here. I'm going to rewrite it now. 2 times 3 is 6. 2 times -5 is -10 equals 2 times -9 is -18. So now I've got the new first equation and the old second equation. I could recopy if I want to this second line down, but since they're already stacked, I'm going to use them now, and I'm going to add straight down. -6 and +6 is 0. -10 and +10 is 0. Oh, look at that. Letters went away. That's a big clue. Get ready. These I can put together as -2. So look at this, people. We lost our variables. They completely went away. That's a clue. Get ready. Something special is going to happen. So this is saying that 0 equals to -2. That is a huge no. That is not a true math statement. So because we lost letters, we know that there's a special answer. And because this situation is not a true math statement, we know that there's not one letter in the universe that's going to make this work. So we say no solution. That means if you graphed them in Desmos, they would be parallel lines and never cross. So again, sometimes special things happen. If I would have gotten a 0 equals 0 there, like we did on an earlier problem, that would have been infinitely many solutions and one line would have landed on top of the other in decimals. But since it's a false statement, that's what makes us say no solution. So that is target 5 for unit 1. I will upload this and link it to your target sheet, and you can rewatch it whenever you want. Thanks for listening. Talk to you soon.